The title of my presentation is Fatigue Crack Path Simulation in the Local Residual Stress Field Caused by Static Indentation in the Vicinity of the Crack Tip. This presentation is prepared together with my colleague, Professor Igor Razumovsky, and PhD student Aleksandr Fedorov. Outline of presentation. First of all, I'll give brief introduction in the problem under consideration. After that, we will consider numerical modeling of indentation, fatigue crack growth, and crack trajectory. And of course, we will consider fatigue crack growth and trajectory in the local residual stress field caused by static indentation in the vicinity of the crack tip. In the case of semi-elliptical surface crack under tension and compact tension specimen. And finally, conclusions. The indentation method as a test method is widely used to determine the mechanical properties of structural materials. At the same time, local indentation in the vicinity of crack tip by means of the spherical indenter can lead to a significant decrease of fatigue crack growth rate. So the aim of present paper is to investigate the effect of local residual stress field on the rate and the fatigue crack path. Static indentation by a spherical indenter is considered as a method for creating a residual stress field. It's quite obvious that numerical modeling is also the optimal way to solve the considered practical problem and determining the indentation parameters. A specialized algorithm has been developed in the ANSYS software to predict the effect of residual stress field in the vicinity of crack tip on the rate of fatigue crack growth. The point or points of indentation was located both symmetrically related to the line of initial crack orientation and with some offset. In some cases, the fatigue crack can change the trajectory in the residual stress field and propagates under mixed mode loading. That's why the Paris law in terms of equivalent stress intensity factor is used for fatigue crack growth simulation. The angle of fatigue crack propagation is determined according to the maximum average tangential stress criterion. Two typical problems of fatigue crack growth are considered, namely, a semi-elliptical crack in plane under tension and plane crack in standard compact tension specimen. Specialized algorithm has been developed in the ANSYS software. The algorithm uses the ANSYS explicit CTR solver, which is fully integrated into the unified calculation module Workbench Mechanical. The algorithm allows determining the field of residual stress as a result of indentation. After that, to carry out numerical modeling, the fatigue crack growth. These two procedures are combined into one in which there are common sections, namely mesh, fracture, and so on. Calculation of crack length increment is performed by calculating the length of the separate open finite elements describing the contour or surface of crack edge in the vicinity of the crack front. The change of crack length is the sum of lengths of the open finite element belonging to crack edge for the plane problem. In the case of three-dimensional problem, the change in the crack length is determined by change in the position of each node of crack front, and it's the sum of change in the finite element lengths, which are located in the direction of crack growth. The tetrahedral finite element mesh is employed for calculating the fatigue crack growth, taking into account the need to calculate the residual deformations in the indentation zone. The finite element mesh has a local additional thickening. Calculation of the fatigue crack growth is performed for the case when a local residual stress field obtained by indentation takes place in the zones where the crack reached the surface, both made from structural steel with a diameter of 5 mm is considered as indentous. The case was investigated when the point of the first contact between the indenter and the plate is the point where crack reaches the surface. It is assumed that there is no friction between surfaces on the indenter and the plate. In this case, the maximum value of displacement on the indenter is around 60 micrometers, and the maximum residual displacement is 45 micrometers. The obtained results clearly show that a sufficiently small value of the force on the indenters can lead to significant decrease of the crack growth rate. This concerns not only the effect of indentation for points where crack reaches the surface, but also for the point far from the surface. The standard compact tension specimen is used to estimate the effect of indentation on fatigue crack growth and crack path. The scheme of CT specimen, as well as finite element model, is shown in this slide. In order to increase the zone of indentation influence on the fatigue crack growth rate, a small specimen thickness is considered. The geometric and mechanical parameters of the indenter are the same as in the above-mentioned problem. A schematic of finite element subdivision of specimen surface is shown in this figure. The points in the vicinity of crack tip on the specimen surface are subjected to indentation by two spherical indenters, diameter 5 mm, with a force 100 Newton. As a result, a residual stress field is created, and maximum value of residual displacement is 8 micrometers. A symmetrical cycle with maximum stress 100 megapascal is under consideration. And you can see the distribution of residual equivalent stresses at the point of indentation. This slide shows the calculating curves of a fatigue crack growth, which are obtained for the case of absence and presence of an indentation. The results show that indentation in the crack tip leads to the decrease of crack growth rate on the basis number of sites around 100,000 by more than 3 times, even at very low residual stresses. This allows concluding that the use of this technique is promising for extending the residual life of thin wall structural elements with through thickness cracks. In this case, the indentation points are displaced related to the plane of symmetry of the specimen YX plane by some delta Z and relative to the crack tip in the direction of X axis by delta X 2 millimeters. it can be assumed that the influence of indentation force on the crack growth rate and changes of crack trajectory will decrease with an increase of tensile load. This is confirmed by the result of calculations which show the corresponding dependencies for the case of indentation by force 450 Newton to point K with delta X 2 mm and delta Z 4 mm, and subsequent cyclic loading by force 15 Newton and second force 90 Newton. The effect of value of static force, which is applied to the indenter on the fatigue trajectory, is also analyzed for the case of maximum cyclic load 100 megapascal and the constant position of the indentation point. It can be seen that the increase of indentation force leads to a significant deviation of the fatigue crack trajectory from initial direction for the case of the same localization of the indentation point and the cyclic load. When the indentation force reaches a certain value, P star, the crack can propagate in the opposite direction to the original orientation of the crack. This circumstance can be sufficiently employed to control the fatigue crack growth trajectory. And conclusions. The method and the algorithm in the ANSYS software for numerical modeling of fatigue crack growth under mixed mode loading have been developed taking into account the influence of the local residual stress field caused by static indentation in the vicinity of the crack tip. The indentation in the vicinity of semi-elliptical crack tip, where the crack reached the surface, can lead to the significant decrease of the fatigue crack growth rate, not only in the vicinity of the indentation zone, but also in depth of the plate under tension. It's demonstrated for the CT specimen that when the indentation point is located relative to the initial crack propagation line, there is a significant deviation of the fatigue crack trajectory from the initial direction. Moreover, the fatigue crack can propagate in the opposite direction to the original orientation of the crack at certain parameters of the problem. I mean the point of the indenter, the value of indentation force, the value of cyclic load. Thank you very much for your attention.